Okay, welcome everybody to the next video. My name is Mr. Galindo, and again we are working on our computer-aided manufacture process, video 4 now, I believe. So we have created a left setup, we've got the drill, we've got the parallel, and for most people that probably would actually be fine making the car. You could just do one half, we could do the other half now, and that would be okay. But actually it wouldn't. And the reason it wouldn't is because for a lot of you, you have made modifications to your vehicle which has changed how thick and thin some of the parts of your vehicle design are. And so because of that, we're going to do a slightly more sophisticated toolpath. So we are going to insert an adaptive clearing code to remove most of the material before we do this super fast parallel, because that will then give us a higher chance of actually being able to produce everything without damaging it. So this parallel we're going to use as the template for our adaptive clearing toolpath. And so we right click on it, select create derived operation, 3D milling, we're going to go adaptive clearing. The adaptive clearing is going to be pretty much ready to go. The only thing we need to do is change the cutting feed rate to 2,500 millimeters a minute. Click to the passes, check that that's the right settings, which it's not. Under passes at the very top we've got maximum roughing step down. That should be 18 millimeters, and then if we scroll down, the radial stock to leave, I'd like 2 millimeters of spare on all my design. Then we should be able to go to heights, double checking that that's stock top origin. Yep, so that's why we used a derived operation. It keeps all the settings, and you'll see now it will create quite a funky looking path, toolpath that is, where it machines and removes most of the material. So if we now move that adaptive above the parallel, we can do a simulation on the whole left setup. Simulate. I'm going to change this to ceramic so it's slightly easier to see, but change the colorization to operation. And then starting on the left side, we've got the drill and the other drill, and then we're starting our adaptive. No errors yet. And then we've got our parallel. If you hover over these two sections here, you can see the approximate machine time. The adaptive takes 31% of the time of the whole manufacturing process for one side, and it takes 5 minutes, whereas the parallel takes 67.1% of the whole time for the side code, and it takes a total of 11 minutes, 23 seconds, approximately. So having visualized that now, you can see how much less material it's got to take away by doing this process. And look at that. What a finish. Perfect. That's not going to leave you much sanding to do, which everyone will be happy with, myself included. Alrighty, perfect adaptive code. So now that we've got a setup for one side completed, we're going to create the setup for the right-hand side. Basically, because you've done one, all you need to do is put it onto the opposite side of your vehicle. And to do that, we just simply duplicate the setup, rename it, right, setup, and then edit it. When we edit it, we need to flip the two orientation tools for the work coordinate system. So we flip the Z, flip the Y, make sure that the X is still pointing out towards the end of the spigot here. Click OK. We expand the right setup. Notice the exclamation marks. Just means that your code needs to be generated. So right click, generate, right click, generate, or if you clicked on the whole setup folder, you could have done the same thing. Right click, generate, and it would have done all of them in one go. Having done that, I should be able to now cycle through drill, adaptive, parallel, drill, adaptive, parallel. One last check by clicking the setups folder and going simulate. Rather than actually watching it do it now, I'm just going to click this go to end of toolpath, and my computer will start to simulate the process it would take for manufacturing it. You can see it's going through the stages there, the bar there along the bottom tracking its progress. Pretty quick. And I spy with my little eye, absolutely 0 errors. Now that is pretty darn good, pretty darn handy. Got axle holes the whole way through, the car looks nice and machined, just got that tiny little bit of wood I'd have to cut off with a Stanley knife. And for my design, which is kind of a bit of an amalgamation of Year 9 and Year 10 F1 courses, the Year 10 F1s obviously get to do a 3D printed rear wing, so that's pretty cool. And that's ready to go there. So that is a completed simulation, and you have successfully programmed in for your manufacture process 6 separate operations, and you have managed to design a tool bit, and you've created a pathway for it to follow to manufacture your car. So this is nearly the end of the course for making a car code. Congratulations, and I'll see you next time.